So, last class I have discussed about the calculation of settlement of foundation on clay. Now, this class I will discuss how we will calculate settlement of a foundation resting on sand and what are the methods that we will use to determine the settlement. So, these are the summary of all the methods that I have discussed to calculate the immediate and the consolidation settlement of clay and the calculate of the settlement of foundation on sand. And in case of sand or granular material, this settlement all are immediate settlement. So, one thing I want to mention that this is P 0 bar, this is effective, this is also effective. So, here you if you see that here P 0 bar is using and here sigma 0 bar is using. So, both are same. So, both are effective overburden pressure. So, either we can use as a P 0 bar or sigma 0 bar, both are effective overburden pressure. So, keep it in mind. And another one is that, so when you are talking about the immediate settlement, so for the immediate settlement calculation of clay, we are using this expression only, because this is the expression for the clay immediate settlement calculation, or this is based on the elastic theory, and this is the consolidation expression, settlement expression. And for the granular soil, so as I mentioned, so we will using these 4 methods, but you can use this expression also, this immediate settlement calculation expression for which we are using for clay. Sometimes we can use these expression also, but I would prefer to use these expressions which are mentioned in the immediate settlement calculation, because in the case of sand we can do the in situ test. So, these expressions or these methods are based on in situ test like plate load test, SPT, SCPT, except the 4th one which is based on the semi empirical methods. So, but if we do not have any of these methods available, then we can use this expression also. So, sometimes we can, so that means this is applicable clay or sand also, but again I am mentioning that I would prefer to use any of these in situ test based method for sand settlement calculation. So, in your assignment or the exam also it will be mentioned, if it will either it will be mentioned that which method you have to adopt, or based on the given values of soil parameters, either it is SPT or SCPT or plate load test, you have to select any of them which is listed here. So, either you can go for this all in situ based test method, or sometimes we can use the sand this expression based on the elastic theory which we have used for the clay. So, keep in mind, and another one that today I will discuss about the settlement calculation of the sand, and I have already discussed about this plate load test part, because here how the settlement can be calculated based on the plate load test data, or how we will get the allowable load bearing capacity of a foundation based on the plate load test data. So, these things been discussed. So, and one thing I want to mention in the plate load test, the problem that I have solved in the plate load test case. So, here I have introduced the water table effect also. Keep in mind that you will only introduce the water table effect if the plate load test is done above your natural water table. I mean, that means during your test of the test on the site, your water table was far below from the influence zone of the plate. So, in that case only, if the water table rise is happened, then only you have to introduce the water table effect. If the water table is always there within the influence zone during the test, then that thing you no need to consider. But and all the problems that I have solved, that there the water table was not there during the test condition, and that is why we introduce the water table effect. This is one thing. Another thing, in plate load test, sometimes using of one single plate, we are using two plates also. So, how it will help? So, it will help, suppose you are using, so this is the plate load test. So, if you are using two plates of, say, one is perimeter or area A 1 for one plate and perimeter P 1 for another plate. So, we can use this expression A 1 M plus P 1 A is the Q 1. So, what is that? That A 1 is the area of first plate, P 1 is the perimeter of the first plate, and Q 1 is the load carrying capacity of the plate. And then if you do another test, A 2 M plus P 2 N is equal to Q 2. Okay? So, that means the Q 2 is the load carrying capacity of the second plate, where A 2 is the area of the second plate and P 2 is the perimeter of the second plate. So, if we have these two expression, from there we can calculate the M and N. Now, based on these M n, we can now determine the load which any plate or any foundation can carry. So, this is the another way we can do it, and but most of the cases we follow the single plate expressions also, by which also we can determine the load carrying capacity that I have explained. So, but today I will discuss about the methods which are based on. So, first I am taking one problem, the example problem that I am taking. So, settlement calculation of foundation resting on sand. So, last class I have calculated the settlement of foundation resting on clay. Today, I will calculate a settlement of foundation resting on sand. And the problem, that example problem that I am taking, so this is the ground surface and here we have a foundation. Okay. So, this is the GL, ground level, and water table is as the base of the foundation. And the last problem on clay, I have taken a raft foundation. Here I will take a isolated footing. So, it is I am taking a isolated footing. So, this is the water table location. So, this is plus 0 meter. So, water table is at minus 1 meter. So, and it is the 2 layer soil system. So, this is the layer 1 up to this is layer 1. So, this is layer 1, this is layer 2, layer 1 is minus 5 meter and the layers 2 is extended up to minus 11 meter. So, this is the problem, an isolated footing. And the soil, so the layer 1 which is medium sand, and the layer 2 also medium sand, but which different properties. So, properties that are taken, the unit weight of the soil is 18 kilonewton per meter cube for first layer QC cone resistance is 10,000 kilonewton per meter square, and the E value elastic modulus of the soil is 25,000 kilonewton per meter square. So, this is for the layer 1, and similarly layer 2 unit weight is again 18 kilonewton per meter cube. QC cone resistance is 12,000 kilonewton per meter square. E value is 30,000 kilonewton per meter square, and the dimension of the footing. So, it is a square isolated footing of dimension 4 cross 4 meter. So, the width of the footing B is 4 meter and the depth of foundation or DF is 1 meter. So, now which are the methods we can use here. So, as I mentioned, if any of the particular methods is mentioned, then we can use that method, but here no particular methods are mentioned. So, you have to check that what are the methods we can use. So, the first method that we can use, the method based on the CPT, SCPT, because this SCPT data is given. So, E value is also given. So, that is how we can use the method 4 also, D, that is semi empirical methods, but we cannot use the n value methods here, because that n value is not given here. So, it is only QC value is given. So, and the plate load test is not done. So, plate load test also not given here. So, we can use method 3 and 4, and in addition to that, as I mentioned, we can use the elastic theory also to calculate the immediate settlement that I have used for the clay immediate settlement calculation. So, that method also we can use, but I would prefer that I will use these two methods which are available. QC is available, then we can use that method only, but here I will show all the 3 methods that we can use in this case. So, and the thickness of this first layer is 4 meter and the thickness of the second layer is 6 meter. And as we are doing the settlement, so the influence zone is 2B. So, the influence zone is twice B. So, up to 8 meter. Okay. So, it is up to 8 meter, but this thickness of this layer is 4 meter from the base of the footing. So, 6 meter, this is aptimeter from the base of the footing. So, here up to 8 means, suppose your influence zone is up to here. So, influence zone, the second layer thickness up to the influence zone is 4 meter. Okay. So, now the methods that we are talking about. So, first method that we will do, it is based on the SCPT. So, from SCPT data, and the expression is given for the SCPT value, that is immediate settlement SI is the summation of 2.3 by C, H is the thickness of the layer, log 10, sigma 0 or P 0 bar or del sigma. or sometimes we can write summation of 2.3 as I mentioned H log 10 P 0 bar plus del P divided by P 0 bar. So, again we have to calculate the P 0, the middle point of each layer. So, this is the middle point of this layer and middle point is 2 meter from the base of the footing, and here it is not the middle point of this layer, because here the total layer is second layer is not within the influence zone. So, it will be the middle portion of the thickness of the layer which is influenced by the foundation. So, the influence zone thickness for the second layer is 4 meter. So, we have to take the point B, which is again 2 meter from the top of the second layer or bottom of the first layer. So, I can for point A. So, we have to calculate that what are the stresses coming in the point A. So, point A P 0 bar is equal to the top, as I mentioned there is only one unit weight given. So, that we will use for the unit weight above the water table and for the saturated both. So, if there is two different unit weights are given, so we have to use both depending upon which unit weights are given. Here only one is given. So, that is why we will use the one only. So, the P 0 bar for the thickness above the ground base is 18 into 1, that is the overburden pressure, plus for this one is 2 meter. So, 2 into 18 minus 10, because 10 is the unit weight of water which is taken as. So, 10 is the unit weight of the water is taken 10 kilonewton per meter square. So, this value is 34 kilonewton per meter square, and del P, as we are taking it is 1:2 or 2:1 distribution. So, as I mentioned, so del P will be, so the total load which is coming on the foundation Q is given 2000 kilonewton. Okay. So, total load is 2000 kilonewton. So, the Q net, which is including the load Q is including the weight of the footing. So, the Q net which is coming as 2000 kilonewton divided by the 4 cross 4, 16. So, the net intensity that is coming out to be 125 kilonewton per meter square. So, that is the load which is acting on the base of the footing. So, this is the net load, net stress which is acting on the footing is 125. This stress is due to the application of external load. So, this load including the load coming from the superstructure plus the foundation weight. So, so that means del P will be 125 into 4 cross 4 divided by 4 plus 2, and then the other side 4 plus 2. So, this 2:1 method I have discussed in the last problem when the settlement of foundation resting on clay that was calculated. So, we are using the same methods we are following, and we are getting the del P at point A is 55.55 kilonewton per meter square. So, similarly, for point B, the P 0 bar is equal to 18 into 1 plus now the 4 meter 4 into 18 minus 10 plus this 2 meter, okay, at B. So, plus 2 again 18 minus 10, because here also unit weight is 18 kilonewton per meter cube. So, it is coming out to be P 0 bar is 66 kilonewton per meter square. Similarly, del P at point B is 125 cross 4 divided by 4, then 4 meter plus this 2 meter, 6 meter. So, plus 6, again 4 plus 6. Okay, so, this will give 20 kilonewton per meter square. So, these are the things are given. So, now the next one is that so, as I mentioned that now our immediate settlement S I is equal to 2.3 divided by C into H log 10 P 0 bar plus del P divided by P 0 bar. So, this is summation. Now, the C value we can calculate based on two methods. The C value is equal to 1.9 into Q C divided by P 0 bar. So, this is suggested by Meyerhof, or I can use C is equal to 1.5 into Q C divided by P 0 bar This is given by De Beer and Morten. Okay. So, if I use the Meyerhof expression, then the C1 for the first layer will be 1.9 and QC value for the first layer is the QC value for the first layer is given 10,000 kilonewton per meter square and QC value for the second layer is 12,000 kilonewton per meter square. So, I can write this is 10,000 divided by P 0 bar. So, P 0 bar for the first layer is 34 and P 0 bar for the second layer is 66. So, this will be the 34. So, this value is 558.8. Similarly, C value for the second layer, layer 2, this is for layer 1 is 1.9, this is 12,000 divided by 66. So, this is coming out to be 345.5. So, finally, if I write the immediate settlement, I can write this is equal to 2.3 and the thickness of first layer is 4 meter and second layer is 6 meter, not 4 meter, not 6 meter, because 4 meter is only up to the influence zone. So, remember that thickness of first layer is 4 meter and the thickness of second layer is 4 meter also, because we have to consider up to the influence zone only. So, that means this is 2.3 for the first layer into 4 divided by C. C for the first layer is 558.8, then this is log 10 P 0 bar is 34, then del P is 55.55, then divided by 34. Then plus for the second layer 2.3, again thickness is 4 meter, C is 345.5, then log 10, P 0 is 66, del P is 20, P 0 bar is 66. So, we can write this value is 6.92 plus 9 plus 3.06. So, total settlement is 9.98 millimeter. Okay. So, next one is that now if I use the from this settlement. So, we have to apply the correction factor. So, what are the correction factor we have to apply? That as I mentioned, for the immediate settlement we have to apply the correction factor for the rigidity correction factor and the depth correction factor. But as this foundation is the isolated footing, so it is not a rigid foundation. So, we will apply only the depth factor correction. So, depth factor corrections. So, you know the D is D root over L B. So, here D value is 1 meter and L B is root over 4 cross 4, and because your L is equal to B is equal to 4 meter. So, this correction, this value is 0.25 and L by B is equal to 1. So, correction factor is equal to 0.94 from the Fox chart. So, this Fox chart I have given. So, SCI corrected will be equal to 9.98 into 0.94. So, that is equal to 9.4 millimeter. So, as per the this is as per the Meyerhof. Now, if I want to calculate the settlement SE corrected as per the De Beer and Morten, then this value is, because if you see here these things are. So, this is the Meyerhof or De Beer by Morten divided by Meyerhof. If I say this is the divide, if I say this is the C for the Meyerhof and C for the De Beer by Morten. So, that will be equal to 1.9 divided by 1.5. So, because this is one value. So, that means the we can write the corrected value for the De Beer and Morten. So, instead of this is 1.9, we have to use this is 1.5. So, all the CI value will change. So, all the CI value will change as the CI value is we are dividing the C value. So, what will happen? So, for this case De Beer and Morten case, C value is lower than the C value as proposed by Meyerhof, because it is 1.9, it is 1.5. So, C value that we are getting by using De Beer and Morten will be lower than the C value that we are getting by Meyerhof. So, now if I divide that lower value in the final expression. So, our settlement that we will get by using De Beer and Morten will be higher than the settlement that we will get by using the Meyerhof. Okay. So, the De Beer Morten settlement will be, because Meyerhof settlement we have, and higher means this will be 1.9 divided by 1.5, because this is the factor 1.9 1.5, because the Meyerhof value will give lower compared to the the value that we will get by using Debye-Morton. So, this value will be 12 millimeter. So, this is the another value that we are getting. So, this is the settlement we are getting. So, next one that if we use the next approach. So, the next approach is based on semi empirical method. Okay. So, the settlement that we are getting based on semi empirical method. So, which is proposed by Buisman 1948. So, which is also similar to that SI is the summation of 2.3 P0 bar divided by E into H log 10 P0 bar plus del P and P0 bar. So, all the values are calculated for the P0 bar at the center of the same procedure you have to follow, but only instead of C we have to use the E, and this is the P0 bar we have to also used here. So, now if I use that semi empirical methods. So, then for the semi empirical methods. So, our E for this first layer is 25,000 kilonewton per meter square, second layer is 30,000 kilonewton per meter square. So, finally, I will use this is 2.3 and P0 bar for the first layer is 34 divided by 25,000 into thickness again 4 meter. This is log 10, P0 bar is 34 plus 55.55 divided by 34, then plus 2.3 into 66 divided by 30,000 into again H is 4 meter, then log 10, this is 66 plus 20 divided by 66. So, this will be 5.3 plus 2.33. So, this will be 7.63 millimeter. So, again the SI corrected will be 7.63 into 0.94. So, that is equal to 7.2 millimeter. So, this is the values that we are using here. So, the next thing is the elastic theory. So, this as I mentioned, we can use this one also for the sand immediate settlement calculation, but though I have not listed it in the list that I have given for the in the summary list, but this is mainly used for the clay, but I would prefer that if you have the other values that like SPT, SCPT, or then we should use those value and those methods to determine the settlement or immediate settlement, but this method also you can use, but and that means this method is that immediate settlement SI is equal to your Qn B divided E 1 minus mu square into IF. Okay. So, Qn value is here, Qn is 125. So, Qn is 125, B value is 4 and 1 minus 0.3 square. So, remember that for the clay generally mu value we take 0.5, but for the sand the mu value take 0.3. Okay. And the IF value we are taking it is equal to 1.12 from the table. because this is for the square footing, IF value for square footing. It is, and it is flexible foundation. So, at the center from the table we are taking IF value is 1.12, but the E value, as this is the 2 layer. So, again you have to take the weighted average. So, A value average we are taking is equal to 25,000 into 4 plus 30,000 into 4 divided by 8. So, this will be the 27500 kilonewton per meter square. So, we can divide it by 27500. So, final value that is coming 125 into 4, 1 minus 0.3 square and 2700. So, and then we have to apply the correction factor 0.94, because this is the depth correction factor. So, the value will be 17.42 millimeter, and that is corrected. So, we have basically 3 methods we have used, because the data those are given, we can use for the 3 methods. Other 2 methods like SPT and the plate load test that we can use, cannot use here because those data are not given. So, based on that we got a settlement value 17.42 for one method, another method the corrected value is 7.2 millimeter, and then other two is 9.4 millimeter and 12 millimeter. So, here it is around 9 and 12, and this value is around 7 point. So, from 7.2 and this is 17.42. So, we can see that here this elastic theory is given very high value or higher value of the settlement compared to the other methods that we have used, and then this semi empirical methods is given lower value among these 3, and this is given in between them. So, again I recommend that if the SPT or SCPT data are given, you use those theories or methods determine the settlement value, but in the exam or in your assignment, if any methods is mentioned, then you have to use that method only. Otherwise, depending upon your available soil parameters, you can use respective settlement calculation methods. Because I have discussed the plate load test, I have discussed the elastic theory, I have discussed the semi empirical methods, I have discussed the SCPT based settlement calculation, or full I have discussed, but only SPT based settlement calculation is remaining. That I will discuss in the next classes when I will design the foundation on sand. Thank you.